All right, let's find a vector r with the given magnitude of r being 9, in the same direction as the vector u in component form have 3 and 7. So remember, a vector is really just a triangle, a horizontal component and a vertical component. That vector u is telling us that the horizontal component is 3 and the vertical component is 7. So let's find the hypotenuse of this right triangle, aka the magnitude of this vector u. We know it will be the square root of 3 squared plus 7 squared, which is the square root of 9 plus 49 is a 58. Note that 58 is 2 times 29, two prime numbers, so we cannot reduce this in any way, so we will just leave that as the square root of 58. Now, we want a vector v, or vector r, to have the same direction as this, which means it needs to be a similar triangle. So we want the hypotenuse to have a length of 9. So let's figure out what this horizontal and vertical component needs to be. Well, a good way to look at this is to remember your geometry and remember that we have similar triangles, and so the ratio of the sides are proportional, which means we can set up the proportion x over 9 equals 3 over root 58. Notice that's the bottom side of both triangles divided by the hypotenuse of the triangle. Then x has to equal 3 times 9, which is 27, over the square root of 58, which we would rationalize as a 27 root 58 over 58. That's the x component. What about the y component? Same idea. We're going to take y over 9 equals 7 over root 58. And in the exact same way, we're going to get 7 times 9 is 63. Divided by root 58 will give us 63 root 58 over 58. Now, that is a vector in the same direction as u, with a magnitude of 9, and we need to write the actual vector out. So let's write it as, open that bracket up, the x component is 27 root 58 divided by 58, comma, the y component 63 root 58 over 58, and we are done. That is vector r.